Article 220.87 addresses calculating feeder or service loads that serve existing loads. It generally requires increasing the existing load by 125%. However, the interplay with Article 215.2 and its exception is crucial. Article 215.2 dictates that the minimum feeder conductor size shall not be less than 125% of the continuous load plus 100% of the non-continuous load. The exception to 215.2 introduces a conditional allowance. If the overcurrent device is specifically rated for 100% of its rating, then the minimum feeder conductor size shall not be less than 100% of the continuous load plus 100% of the non-continuous load. The core question lies in whether the 125% increase for existing loads under Article 220.87 is still mandatory when employing a 100% rated overcurrent device as permitted by the exception to Article 215.2. The answer is no. When utilizing an overcurrent device rated for 100% of its rating, you are not required to apply the 125% increase to the existing loads under Article 220.87. Here's why. Firstly, Article 220.87 focuses on determining the existing load for feeder and service calculations. It's a method to ensure adequate capacity for existing installations when adding new loads or evaluating the existing system. Secondly, Article 215.2 and its exception primarily address the sizing of feeder conductors. The standard rule requires a 125% factor for continuous loads to account for sustained operation. The exception allows for a reduction in this factor when using a 100% rated overcurrent device, acknowledging its capability to handle the full rated load continuously without derating. Thirdly, the exception to Article 215.2 directly modifies the conductor sizing requirement based on the overcurrent device rating. It specifically states that the conductor size needs to accommodate 100% of the continuous load when a 100% rated overcurrent device is used. This implies that the overcurrent device is designed and tested to operate at its full rated capacity without the need for the additional safety margin traditionally provided by the 125% factor. Fourthly, applying the 125% factor from Article 220.87 in conjunction with the 100% rated overcurrent device exception in Article 215.2 would result in an unnecessary oversizing of the feeder conductors. The 100% rated overcurrent device already accounts for the continuous load without requiring the additional 25% margin. Fifthly, it is important to carefully review the manufacturer's specifications for the overcurrent device to ensure it is indeed rated for 100% continuous operation. Not all overcurrent devices are designed for this purpose, and using a standard overcurrent device with exception to Article 215.2 would be a violation of the code. Sixthly, the NEC intends for these sections to work in harmony, not in conflict. The allowance of 100% rated overcurrent devices is a specific provision that takes precedence over the general requirement of increasing existing loads by 125% when sizing feeders. Seventhly, consider a scenario where an existing load is determined to be 80 amps. Without the exception, Article 220.87 would require using 100 amps for the load calculation. Article 215.2 would then require a feeder size to handle 125% of any continuous load plus 100% of any non-continuous load. However, if a 100% rated overcurrent device is used, the existing load remains at 80 amps for the purpose of feeder sizing, and the feeder must be sized to handle 100% of that load, provided the overcurrent device is properly selected and applied. Eighthly, the 125% factor in Article 220.87 is primarily aimed at addressing uncertainties in load assessment and providing a safety margin for typical installations. With 100% rated overcurrent devices, this safety margin is incorporated into the device's design and testing. Ninthly, it is imperative to maintain accurate records and documentation for all electrical installations, particularly when utilizing 100% rated overcurrent devices. This includes documenting the manufacturer's specifications, load calculations, and the basis for selecting the specific overcurrent device. 10thly, always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and standards. The NEC is a complex document, and interpretations can vary. Understanding the specific requirements and nuances of the code is essential for safe and effective electrical installations. 11thly, while this explanation provides general guidance, it is crucial to review the specific wording of the NEC and any applicable local codes or amendments. The final determination of code compliance rests with the authority having jurisdiction. 12thly, the use of 100% rated overcurrent devices can offer potential cost savings by reducing the required feeder conductor size. However, this must be balanced against the potential for increased heat generation within the overcurrent device itself. Proper ventilation and heat dissipation must be considered in the design of the electrical system. 13thly, it's important to distinguish between continuous and non-continuous loads when applying these code provisions. A continuous load is defined as a load that operates for 3 hours or more at a time. Non-continuous loads are those that operate for shorter durations. The 125% factor in Article 215.2 applies only to continuous loads, unless a 100% rated overcurrent device is used. 14thly, consider the impact of voltage drop on feeder sizing. Voltage drop can reduce the efficiency and performance of electrical equipment. The NEC recommends limiting voltage drop to 3% for feeders and 5% overall. This may require increasing the feeder conductor size beyond the minimum required by Article 215.2. 15thly, the selection of overcurrent devices should always be based on the ampacity of the conductors they protect. The overcurrent device must be sized to protect the conductors from overloads and short circuits. The ampacity of the conductors must be determined in accordance with NEC Table 310.15b16 and any applicable directing factors. 16thly, when calculating the load on a feeder, it's necessary to consider all connected loads, including lighting, receptacles, motors, and HVAC equipment. The load calculation should be based on the nameplate ratings of the equipment or the values specified in the NEC. 17thly, the NEC provides various methods for calculating feeder loads, including the standard method and the optional method. The optional method is typically used for dwelling units and can result in a lower calculated load than the standard method. 18thly, the use of energy-efficient equipment can reduce the overall load on a feeder and potentially allow for smaller conductor sizes. This can result in cost savings and improved energy efficiency. 19thly, it is important to periodically review the load on a feeder to ensure it is still adequate for the connected loads. Changes in occupancy or equipment can result in increased loads that may exceed the capacity of the feeder. 20thly, the NEC is updated every 3 years, so it is essential to stay current with the latest code revisions. Changes in the code can affect the design and installation of electrical systems. 21stly, be aware of local amendments to the NEC. Many jurisdictions adopt the NEC with modifications to address local conditions or concerns. These amendments must be followed in addition to the NEC. 22ndly, remember that electrical work can be dangerous. Always follow safe work practices and use appropriate personal protective equipment. If you are not qualified to perform electrical work, hire a licensed electrician. 23rdly, the information presented here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or inspector before undertaking any electrical work. 24thly, consider the impact of harmonics on feeder sizing. Harmonics are non-sinusoidal currents that can increase the heating in conductors and equipment. If significant harmonic currents are present, it may be necessary to increase the feeder conductor size or use harmonic filters. 25thly, the use of solid-state lighting, such as light-emitting diode lighting, can significantly reduce the lighting load on a feeder. Light-emitting diode lighting is much more energy efficient than traditional incandescent or fluorescent lighting. 26thly, when calculating the load on a feeder for a commercial building, it is necessary to consider the demand factors specified in the NEC. Demand factors are percentages that can be applied to the connected load to account for the fact that not all loads will be operating at the same time. 27thly, the NEC requires that all electrical equipment be listed and labeled by a recognized testing laboratory. This ensures that the equipment has been tested and found to be safe for its intended use. 28thly, when installing electrical equipment, it is important to follow the manufacturer's instructions. The manufacturer's instructions provide specific information on how to install the equipment safely and correctly. 29thly, the NEC contains requirements for the grounding and bonding of electrical systems. Grounding and bonding are essential for safety and help to prevent electrical shock. 30thly, when working on electrical systems, it is important to energize the circuit before starting work. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. 31stly, always use a voltage tester to verify that the circuit is de-energized before starting work. This will help to prevent accidental contact with live conductors. 32ndly, when splicing conductors, use approved connectors and make sure the connections are tight. Loose connections can cause overheating and create a fire hazard. 33rdly, when running conductors through walls or ceilings, protect them from damage by using conduit or other approved methods. This will help to prevent shorts and ground faults. 34thly, when installing receptacles, make sure they are properly grounded and securely mounted. Loose receptacles can create a shock hazard. 35thly, when installing lighting fixtures, make sure they are properly supported and wired. Improperly installed lighting fixtures can create a fire hazard. 36thly, when working on electrical systems, always be aware of your surroundings and take precautions to prevent accidents. Electricity can be dangerous, so it is important to be careful and follow safe work practices. 37thly, remember to consider the ambient temperature when selecting conductors and overcurrent devices. High ambient temperatures can reduce the ampacity of conductors and the rating of overcurrent devices. 38thly, the NEC provides tables for directing conductors based on the number of current-carrying conductors in a raceway or cable. When multiple conductors are installed in close proximity, they can generate heat that reduces their ampacity. 39thly, consider the altitude when selecting conductors and overcurrent devices. Higher altitudes can reduce the dielectric strength of air and the cooling effect of convection. 40thly, the NEC requires that all electrical equipment be accessible for inspection and maintenance. Do not block access to electrical panels or other equipment. 41stly, the NEC requires that all electrical panels be labeled to identify the circuits they control. This helps to prevent confusion and makes it easier to locate the correct circuit breaker or fuse. 42ndly, the NEC requires that all unused openings in electrical panels be closed with knockout seals. This helps to prevent dust and moisture from entering the panel. 43rdly, the NEC requires that all electrical boxes be securely mounted to a structural member. This prevents the boxes from falling down or becoming damaged. 44thly, the NEC requires that all electrical wiring be installed in a neat and workmanlike manner. This makes it easier to inspect and maintain the wiring. 45thly, the NEC requires that all electrical work be inspected by a qualified electrical inspector. The inspector will verify that the work complies with the code and is safe. 46thly, remember that the NEC is a minimum standard. You may choose to exceed the requirements of the code to improve the safety and reliability of your electrical system. 47thly, the authority having jurisdiction may have additional requirements that are not included in the NEC. Be sure to check with your local building department or electrical inspector to determine the applicable requirements. 48thly, the NEC is a living document that is constantly evolving. Stay up to date on the latest code revisions and interpretations. 49thly, consider attending electrical training courses to improve your knowledge and skills. There are many excellent training courses available from electrical trade associations, colleges, and universities. 50thly, always prioritize safety when working on electrical systems. Electricity can be dangerous, but with proper training and precautions, you can work safely and effectively. Therefore, understanding and applying these nuances of the NEC is essential for safe and compliant electrical installations.